Hello, welcome to CSC7132, Operating Systems and Networking. This is Brady Chen. Now, Section 8.2, File Directories. A file directory, in many cases, it's called a folder. It's a special purpose file that records information about other files and possibly other directories. So the directory consists of a set of entries, and each containing the name of a file followed by the other information necessary to access the file. So file directories is a special type of file that stores the information about the other files. Now, depending on the operating systems, several approaches exist to organizing the individual file directories into a global directory structure. Now, the first directory structure we're going to talk about is a tree structure directory hierarchy. Now, a tree structure directory hierarchy is a collection of directories organized as following. 1. So every directory points to either 0 or more files or directories at the next lower level. So let's say here's a directory, okay? We use D1 to represent directory. And sometimes this is called the internal ID for the directory. Okay. Now, so that directory D1 points to either 0. So that means it does not contain any file, in this directory, or points to more files. So that directory contains a couple of files. Let's say XYZ. Okay. Now, each letter X represents a file name. So now X is a file name. It could represent a file or could represent another directory. Okay. So for example, X could be another directory, and I use D2 to represent it. And the X is the file name. It's an ASCII name for that directory D2. Okay. Now Y could be the ASCII name for a file. It's actually a file. I call it F1. Okay. Now Z could be another file, F2. Now if there's another one, X, Y, Z, I say T. Okay. So that's another file, ASCII file name, and that file could be a directory. So I call D3. Okay. Now because these X and T are directory, so it's a special file, right? So then each directory could also point to either 0 or more files. So D2 points to more files. That's let's say A and a B. Okay, A could be another directory or could be a file. B could be a file. I call it F3. Okay, so D3 is a directory. There's only one file. Okay, points to one file. So let's say G. Okay, so G could be just a file. F4. Okay, so in that case, this directory D2, D2 is an internal ID and X is the ASCII name for that directory. Okay, now these are the files that the directory D2 points to. Okay, A could be another one, D4. Okay, and then D4 contains maybe 3 files. Okay, UVW. Okay, That's one. Now, number 2, every file or under directory except the root is pointed to by exactly one parent directory at the next higher level. So that means in this case, D2 is a directory, right? So it is pointed to by one parent directory, which is D1. Okay. And the D3 is also pointed to by D1. And this file, like file 3, is also pointed to by D1, right? So each one has exactly one parent directory. Now, what about D1? D1 could have a parent directory. Okay, so then in this case, it's pointed to by, let's say, D0. Okay, so D0 may point to 3 files. Okay, so the first file is, let's say, I, J, K. Okay, so the file name is I, so D1 has the ASCII file name I, so it's pointed to by D0. So D0 is the parent directory. Okay, it's the only parent directory for T1. And the J could be a name for a file. K could be a name for another file, right? Or could be another directory. Okay, let's say, let's say it's file. F5, F6. Okay. Now what about D0? Now D0, if D0 has no parent directory, now in that case, D0 is called the root directory. Okay. So the root of a tree structure directory hierarchy is the highest level directory, which does not have a parent directory. Now in that many case, we simply call it a root instead of D0. And then we use the parenthesis, we use // Okay, that's what most of the operating system like Linux or Unix use. Now, under the tree structured directory hierarchy, a file can be accessed through 2 approaches. One is the absolute path name, the other one is relative path name. Now, let's first talk about absolute path name. So, an absolute path name of a file, we normally use the file name F, which is uniquely identified by internal ID, is the concatenation of the directory and the file names leading from the root to the file F. Okay, so for example, here's the file, and that's the file name, okay, the ASCII name, and this is represented using the internal ID F9. Now, if we try to access F through absolute path name, you have to start from the root. Okay, so the root is represented by /, and then from the root, you're going to go to the next directory, D1, right? And then from D1, then you go to D2. And then F is under D2. Now, remember D1 and D2, these are internal ID for the directory. Okay. It's only actually recognized by the operating system file system. The user cannot see this. Now, what the user can see is the name of the directory. Okay, so in that case, the file name for directory D1 is X. So from the root directory, you're going to access through X, so which is the name, directory name. Okay. Now X is actually represented by the internal ID D1. Okay, so then from D1, you're going to access D5, represented by the T. then you need to actually use the / to separate these file names. Okay, so X represent directory D1, T represent directory D5, and then F is actually under the T, so you can put the F here. Okay, separated by / again. Now that's the absolute path. Okay, you can access the F through absolute path using the absolute path name. Okay, remember we don't use the internal ID, we only use the name of the file or the directory. Now there's another way you can access a file. Let's see. Suppose I want to access a file. Let me change the color. Okay. So I want to access the file A, but using the relative path name. Now, a relative path name is a concatenation of file names starting with the current directory. So suppose I'm not in access the file from the root, but from the current directory. Now, if the current directory is D3, let's say, okay. So now, how can I access the file A using relative path name? Okay. Now, in order to actually navigate the hierarchy both up and down, the file system provides a special convention generally using the two dots to refer to the parent directory. Because in here, you're going to access the file A, from current directory D3. So you have to go from the D3, go up to the parent directory D1, and then from D1 to go up to the root directory, and then go down to access the file A, right? So in that case, you need to go up to the parent directory first. So now we use two dots to represent parent directory. So that means from D3, if you try to access the file A, so you need to go up with two dots, and then the / to separate this. And then from here, you need to go up again, so two dots. So then you reach the root. Now from the root, you're going to access the directory D2. Remember, D2 is an internal ID, right? So you have to use the file name for D2. So that's Y. So then you're going to put the Y. Okay. So under D2, then you have a file name A. So from the current directory D3 to access A, you need to use the relative path name. So you need to, go up, dot, dot, / dot, dot, / and then go down to directory D2 through the file name, the directory name Y, and then the file name A. Again, the internal ID for file A is F3, so that's the internal ID. Okay, so these are two approaches we use to access the file under the tree structure directory hierarchy. The operating system file system provides a set of operations to allow the user to manipulate and use the directory hierarchy. Now, the table here lists some of the operations. For example, change. The change operation changes the current working directory to another directory specified by a path name. Okay, and create a new named directory and a new entry in the current working directory. Okay, which points to the new directory. So also delete operation deletes directory D specified by path name. When you actually apply the delete operation, it will also delete all files and directories reachable using any path name starting from D. So that means when you delete the directory D, it will delete all the files or directories under the directory D. Okay. Now move operation moves a file or directory from one directory to another. Now rename, change the name of the file or directory, specify the path name. Okay. Now list basically listed file names and optionally and other attributes of all files contained in the directory, specify the path name by the path name. Okay. Now to find a file or directory specified by name, this command will actually allows you to find either the file or directory using the name. Okay, so the specific syntax and the semantics of the operation varies between different operating systems. Okay, so for example, in Linux, the change operation can be used by the command called cd, and then you can put the path name, the path. CD basically stands for change directory. Okay, you can also create a directory by using the command. It's called mkdir, make directory. Or if you want to delete a directory, you can use rm, remove directory. Okay. Now the move can be used mv. Okay. Move can also be used to rename a file. Okay, so you can also use a move to rename a file. And the list can actually use ls in Linux to list all the files under the current directory. Okay, so Windows operating system also use its own set of operation. It's these operations are very similar. Okay, so let's take a look at the examples of some of the operations. Okay, now the first operation, change, and then with the path /y, this operation sets the current working directory according to the path, okay, to D2, right? Because the name of D2 is Y. So /y, then this can actually set directory to D2. Okay. Now let's say the next command we're going to perform is to create D, for example. Okay. So now this command gonna create a new directory, okay, under the current directory, which is D2. So then we're gonna create a directory D, okay, and then so once D is the directory name, so the ASCII name. So then the operating system file system gonna create an internal ID for that directory. Okay. At this moment, the directory is empty. There's nothing in there. Okay, so that's the create command, which is going to create a new directory with the name D, internal ID D7. So now, what about the command called rename? So let's say I'm going to actually rename. I'm going to rename, for example, I provide a path /x /t /e and / for rename, you need to provide a path name and a file name to another name. Okay, so let me delete that. Correct the mistake. I'm going to delete this. Okay, yes. So what about this command? Rename the file E to another name G. So where's the file E? So let's take a look at this. So this is actually absolute path name, right? So you can /x and t /t and /e. Okay. So now I'm going to rename the file name E to G. So I'm going to get rid of E. Okay. Change the name to G. Sorry, it's not really that clear. Okay. Now, what about move? So for example, if I use the move command, let's say move, okay, a file, X under the absolute name, XC, and K to another actually path name, /X and R. Okay. So we're going to move the file name from here to another path. Okay, so where's K? So it's under the X and then Z and then K, right? Now where are we going to move to? It's under X, but now it's under R, so that's this one. So we're going to move the K to another directory under the directory R. So in that case, I can simply just move, I'm going to get rid of this, right? It's completely gone. And then I'm going to move to the directory D4 with the directory name R, right? And then, so it's the K, move here, F5. So I'm going to get rid of this one here and just move here. Okay. Now after the move, operation. Now what about list? If I list, the list is going to actually list all the names of all files and the directory recorded in the directory D4. Okay. So for example, if I say list, okay, /X /R. So this is going to list all the files under D4. So you can list the file H, P, and the K now. Okay. So now what about delete? So let's say I delete /X /Z. Okay. So let's see what is this path. So it's X. Let me change the color. So now /X and /Z. So I'm going to delete the Z. So that means I'm going to delete the directory D3, right? Because D3 is pointed to by Z. So the name of the directory D3, that's the internal ID of the directory Z. So I'm going to remove this. So what I'm going to do? So I'm going to remove the Z and remove all the files or directory under Z. I'm going to remove everything under the Z. So the whole, directory and and the files under this directory going to be removed. So that's still D1, right? D1 is still there, but now D1 contains only 2 files. One is R, one is T. Both files are directory, right? Okay. Now, we talked about the tree structure directory hierarchy and all the operations associated with that tree structure directory hierarchy. Now, the main drawback of a tree structure directory hierarchy is that file sharing is asymmetric. Okay, so that means only one directory can be the parent of any file or another directory. So if the other users try to access the file, the user must refer to the file by first navigate up to the common directory and then down to the desired location. So for example, if there's a okay, so here's the root directory. Okay, and then XYZ, and then you X point to another directory D1. Okay, so there's a UVW, and then Y points to another directory D2. Here's a IJ. Okay, so then you actually point to either file or another directory, right? So now, if that's the file, okay, if that's the current location, okay, so the current location is in D2. So if from D2, if you try to access file 1, the file U represented by internal ID F1, then you have to go up to the common directory, which is root, and then go down to access the file 2. Okay, so that's a kind of a big disadvantage. Now, here we're going to introduce a new structure. It's called a directed acyclic directory structure. A directed acyclic directory structure. So a directed acyclic directory structure organizes directory such that any directory at a given level must point to 0 or many files, or other directories at the lower levels, but also permits any files or directories to have more than one parent directory. So that means a file or a directory may have multiple parents. Okay, so now to permit the creation of multiple parents, the file system, the operating system file system provides an additional operation of the form called link path1 path space path2. Okay, which creates a new link from the directory identified by the path name p path1 to the directory or file identifier path2. So that's the existing one. Path1 is the existing one. Path2 is the one you want to create to point to the same file the path1 points to. Okay, let's take a look at the example. Now in this example, the directory D5 has 2 parents. Okay, one is the D1, right? D5 has a parent D1, and the other one is the root, because you have 2 arrows pointing to D5. One is pointed to from D1, the other one is pointed to by root. So directory 2 has 2 parents, D1 and the root. Now the file F8 also has 2 parents, D4 and the D5. let's say parent F8, there's a name, the file name called P and the D4, the directory D4, but it's also under the name of E and the D5, right? Both P and E, these are different name, but it points to the same file, so it has the same internal ID. Okay. Now let's see how can we perform the link operation. Let's say I perform the link operation, link /y p. Now that's the path 1, the first path. And then the second path is /w e. So now this command, link command, creates a new entry named p. Okay, in the directory D2. Okay, now let's take a look at this. So what is the first path? Path 1, that's path 2. Path 1 is y, okay, and then you're going to create a new name called p under directory y, and that directory also is pointing to the same file the path 2 points to. Okay, what is path 2? Path 2 is w and e. So e is actually points to, it's a name of F8. Okay, so that's the one the path 2 actually point to. But now you're going to create a p, also going to point to the same files that the p points to. Okay, or e points to, I'm sorry. That's a link. Okay, now since file 8 is shared equally now by 3 directories. Okay, so D4, D5, and now D2, right? Because of the link command, it just creates another. So file F8 is pointed to by 3 directories. So now the associated reference count, okay, for F8 is 3. So you have to actually count, record the count. Okay. Now why you want to do this? Because if we want to delete F8 using a path, now if the count is 3, that means if you delete one path, it will not necessarily delete the file F8 because there are still at 2 directories point to the F8, right? So delete F8 using the path name. So let's say delete using the path name X, R, and P. Let's say, let me actually change the color here so you can see it clearly. Okay, so now if I delete, use the delete operation with the path. So that's X, R, and P, right? So I actually delete the file using this path name, F8. Now what the operating system file system going to do if that's the case? So it will delete this, okay, and it will not delete F8 because F8 is still pointed to by 2 additional directories. So that's the point. So you can actually delete, this. Let me see whether I can do this deletion. So I can, So I cannot use the operation. So that's fine. So I'm going to delete this. Okay. And then, so once this, file name is deleted, and so then I'm going to update the count to 2, because now this path is no longer there. Okay, so that's the delete. Now, if I try to do the delete command again, for example, so let's say I delete the file. I'm using the path name W and the E. Okay, so let's see. Where's W? W is this. E is here. So then if I delete this /W/E, so you're going to delete this link, right? So you're going to actually delete this link. So, but I'm not going to delete F8 as well, because F8 is still pointed to by P through the directory 2, D2. But there's only one directory currently pointed to F8. So I'm going to update the count from 2 to 1. Okay. Now, if I actually execute the delete command again, the operation again, so that's the last one. If I delete, say, /y/p, now this going to through y and a p. So this time I'm gonna completely delete the F8, delete this and delete this. Okay, because this D2 is the last directory that contains last path that contains the F8. If I delete the file P, then I'm gonna completely delete the file. So that's an advantage of using directed acyclic directory hierarchy. So I can actually make it very flexible. I can point to the same file through different paths. Deleting one path will not necessarily delete the file. Okay, so a directed acyclic directory structure certainly has certain advantages. Now, one of the advantages is that each file may have multiple parents. So that means you can access the files from multiple paths. Okay, so that's good. However, there's a drawback. If a directory is allowed to point to a file or another directory at the high level, then a cycle can form in the hierarchy. Like in this case. So you have a directory D6. Okay. Now D6 is pointing to a file or directory. In this case, a directory which is D1. Now at the high level, D1 is at a high level. Okay. Now this may cause an issue. Let's talk about this. Since D1 is actually at the higher level, now in this case, a cycle is created. So D1 has a directory D3, and D3 has D6, and D6 is pointing to D1. So then you certainly create a cycle. Now, what's the problem with this? Okay. Now we need to realize that the directed acyclic directory structure allows to have multiple parents, right? and they use a count to count how many parents each file or each directory has. So in this case, D1 has two parents. Okay, two parents. Okay, one is root, the other one is D6. So then they use a count 2, which means that the D1 has two parents. Okay, now if we actually perform an operation delete, like a delete /x, so I delete this directory through one path. Okay, that's the root, the path from the root. Okay, so in that case, so it can actually delete /x. However, since the directory D1 has two parents, so this is one of the parents. So the operating system file system only delete this particular path, and it will not delete the directory because the directory has another path, right? And then it will update the count from 2 to 1. Okay, that looks good, right? However, there's a big problem because in that case, the directory D1 as well as D3 and D6, they're isolated now. So they're not connected to the root. They're not connected to the root. Now, what's the problem with this? Okay, now suppose my current directory is D2, and I try to move from D2 to D1. Now, what are you going to do? So typically, what we're going to do is we're going to first actually move to the parent using 2 dots, right? And then from the parents, we're going to go down to find out D1. But the problem is that D1 and the root are disconnected. So there's no way you can access D1 from D2. Okay, so that's the problem. Okay, now how can we solve the problem? Okay, one of the solution is using a directory hierarchy with symbolic link. Okay, so this is a compromise solution. So this compromise solution is to allow only single parent directory for any file, okay, or directory, but to provide a symbolic link to support this file sharing. We still support the file sharing, but not using multiple paths and multiple parents. Now let's take a look at this. Okay, let me first actually delete all the drawings I did. So let's see. Okay, let's delete everything I just did. Okay. Okay. This looks like a acyclic directory structure, right? A directed acyclic directory structure. However, there's a difference. Okay. Now for each file or directory, there's only one parent. So if you look at the diagram, there are two types of links. One is called a regular link. Okay, I use black color. And the other link, I use the green color. It's called a symbolic link. Okay, now for each file or directory, it's pointed to by only one regular link. So that means there's only one parent for this. Now, if you have a multiple link, there's only one regular link. The other two, the other links must be symbolic link. So like this case, like a file F8. F8 has 3 links, right? Only one link. This is the regular link. So F8 has only one parent, that's D5. Now the other two links are symbolic link. Okay, so D4 and the D2, they are not parents. Okay. Now how can we operate this with this? So if you try to execute command delete, okay, let's say if I delete this particular file, F8, through a symbolic link, let's say /y/p, because /y and p, this link is green colored, right? So it's a symbolic link. Now, if I call this delete, I will not remove the file F8. I will only remove the link. Okay. So now what? If I try to delete this F8 through the regular path, okay, so then I delete through regular path. So that means through X, and then through this is through T, and then through E, right? So I delete F8 through this path. And now I find out this path is a regular path. So then I'm going to delete the path and also delete the file. I can delete the file. Even though this F8 is pointed to by a symbolic link, but even though there are two links, but if I delete through the regular link, then I can delete the file anyway, even though it's also pointed to by the symbolic link. So of course I can delete the symbolic link. So it doesn't matter how many symbolic links I have. If I delete the files through the regular link, the file is deleted. So this way you can avoid these, the cycle. Okay. This is a very good solution. Thank you.